This is the 2008 Connected Particles question. We've got a wedge here. We have a mass of 2m here. We've got strings with tension. We've m here. We've two 30-degree angles, and we've 4m. So we're going to have 4mg going down that way. So we're asked to show a separate diagram the forces and then find the acceleration. Okay, let's have a look at the 2m first. We've got this 2m. There's a reaction. We have two reactions, so we'll call them R1 and R2 here. We've got R1 coming this way. And what's going on in the opposing direction? What's going on down this way? And here's my 30-degree angle. I've also got my 30 in here. I've got parallel to the slope. What's my mass? 2m. So just make this one a bit longer. 2mg. And then this direction we have 2mg. It's opposite 30, sine 30. And here we have 2mg cos 30. We can see the forces are going in this direction and this direction. We're looking for acceleration here, so the 2m is going to go down, and this guy is going to go up, and this guy is going to move in this direction. The wedge, because the 2m is heavier, so we call this the direction of acceleration. We call it A. So let's have a look here. We want acceleration, so we want in this direction. Here's my acceleration going in this direction. So we continue our slope and we draw our right angle. And let's say here, so my acceleration is the hypotenuse, and this is corresponding angles of 30. So here I have a opposite, I have sine 30, so that's the acceleration I'm looking for here in this question, the same direction as our forces, this way and this way. And from that we can say, well, we are coming down this way, opposing R1. So we have 2mg cos 30 minus R1. That's what's going on in this direction, and that's equal to m times A, and m is 2m, and we said A was going to be this A sine 30. So that's that one. Let's look at m next. So m is over this side. So I should have put my tension here as well on the string. So we have mg coming down this way. We call this one R2 because it's the second one. And it was the same angle of 30. Put your angle in. 30 and 30. And parallel to the slope. Going down this way. So we have opposite 30. We have this one, mg sine 30, and over this side we have mg cos 30. So I have my R2 in this direction, and I have my mg cos 30 in this direction, so I need acceleration in the same direction. So this is our acceleration line on the horizontal, so we continue our slope and put our right angle in, so that acceleration is our hypotenuse. This corresponds again to 30. So we're looking at this line here, aren't we, to be in the same direction as R2. So this is opposite, so this is going to be M. It's going to be A. By the opposite 30, it's going to be A sine 30 over this side. A sine 30. So the equation for this one will be, well, it's going up the slope. So it's R2 first, so it's R2 minus mg cos 30 is equal to m, which is m times a, which we said up here is a sine 30. We can tidy these up. 2mg by root 3 over 2 minus r1 is equal to 2ma by a half. So the 2's will cancel. So we have root 3mg minus r1 is equal to ma. Or in terms of r1, we have r1 is equal to root 3mg minus ma. And over here we have r2 minus mg by root 3 over 2 is equal to ma by a half. So we have r2 would be equal to ma over 2. And that will be bringing this guy over, we'll make it a plus root 3 mg over 2. Okay, so let's look at the wedge now. We have a couple of things going on with the wedge. We have, let's look at the tension first. It's going to be let's have a look at the direction that it's going in. Tension going down this way. If we create a right angle here, and we have T here along this way, and we have T here along this way. We have a right angle, so if this is my T, this black hypotenuse T, we can create, when we're looking in this direction here, A. So we would want this side here, along here. So that's adjacent to 30, so that would be T cos 30 along here. And obviously this one would be T cos 32, but this is going up, so it might be going in this direction. This would also be T cos 30. Going back this way. So we look at our other forces. Let me draw the triangle on the right hand side, and I have my mass at 2m. So I have r1 going in this direction, so I have r1 going in the opposite direction. I'm going to leave out the line there, so it's going to come down here like this, down here like this. So my hypotenuse is r1, so then this guy along here is what we're looking for. This is 30, so I have opposite the 30, so this is going to be r1 sine 30 along this way. And then on the other side, I have my block, this is the one that's m, I have r2, so that's equal to r2. Then bring my right angle down. I've got my 30, and again this is going to be r2 sine 30. So what's happening in this question? So in this direction, the direction of the acceleration, we have T cos 30 plus r1 sine 30. And then going back in the opposing direction is this T cos 30, so minus T cos 30, and then minus your R2 sine 30. They're the forces. That's equal to m, which is 4m. What's 4m, was that? 4m by acceleration. Okay, what have we got here? We have, well, they cancel. And then we have r1 sine 30, which is r1 over 2, minus r2 sine 30 is r2 over 2, is equal to 4ma. Then we get rid of the 2's. r1 minus r2 is equal to 8ma. We're trying to solve for a. Do we write r1 and r2? We have r2 is equal to ma. Sorry, that's r2 there, just in a 1. Let's get r1. Root 3mg minus ma. Root 3mg minus ma. And then minus r2, which is ma over 2. And ma over 2 and root 3mg over 2. That's the dog drinking our water. Just let's double check this. Root 3 mg minus ma is R1 minus R2, which are both plus, ma over 2 and root g mg over 2. Okay, I was getting distracted. 8 ma. So what can we do here? We definitely divide by m, and we can multiply by 2. Let me multiply by 2 first to get rid of the 2's, and then we'll simplify. So 2 root 3 mg minus 2 ma, then minus ma, and then minus root 3 mg will be equal to 8 ma. No, it won't. It will be equal to 16 ma, you tell me. And now we divide by m. We're going to get 2 root 3g minus this root 3g, so that's just root 3g. We have 2a minus a, so that's minus 3a going across. That will be 19a then over there, 16a plus 3a. So the acceleration of the wedge looks like it's root 3g over 19. This question was going to be on your Christmas test, but Ryan Borderly has put the skates on that.